Hello and welcome to Apologetics 101. Brian here, and today we're going to be discussing the Y chromosome, but more specifically, a Y chromosome paper. Recently, there has been some talk around evolutionists about a Y chromosome paper that has come out recently, and they are trying to claim that it disproves created cons. And interesting enough, the creationists are saying, nope, it actually verifies what we think on this. And so there are two different opposite ways of looking at it. And so we're going to be discussing that today. And we're going to also show what the paper actually shows and what it actually says. And we're going to get right into that right after this. All right, I'm coming at you on a Saturday. At least that's why I'm recording this. You might not see it for a little bit after that because I've got like three interviews next week. One with Dr. Georgia Purdom, a day after that with Dr. Jason Lau, a few days after that with Dr. Carl Werner. So I've got a lot. I'm gonna have a very busy week next week. And then of course the the actual videos are gonna be uploaded shortly after that. So I'm hoping I can get this uploaded soon, maybe even before I do my first interview with Dr. Georgia Purdom, or the next interview I do was with Dr. Georgia Purdom, and uh, hopefully I'll be able to get this out there before then. But anyway, evolutionists have been passing around this particular paper. It's a very recent paper. It came out this year. Basically, the paper is about them fully sequencing the Y chromosome in different primates, a different series of primates, including two species of orangutan, chimp Y chromosome that they completely sequence. Obviously, they're comparing it to the human Y chromosome, which was already sequenced in the telomere to telomere sequence of the human genome, T2T, and they are comparing it to that. They've completely sequenced those, as well as, like I said, two species of orangutan, a chimp, um, let's see, bonobo, and they also did the Y chromosome of bonobos. All right, so the objection by the evolutionists is that they think that it destroys what we think on the Y chromosome. And so, me and Erica actually, well, we didn't fully discuss it. What Erica did, I wanted to know where this particular paper was. I wanted to look at it, and so Erica had gave me the well, I found it right before she gave me the link, because I thought it was this paper. Sent her an email saying, "Is it this?" Turned out it wasn't, but I'd already found the right paper where it was by the time she sent me the email. But she did send me the email, and she did send me the link as well, the confirming the paper that I thought was the one that she was talking about. And so we're going to be discussing that paper today, and we're going to be discussing whether or not if this uh, disproves created kinds or proves it. The first thing that I would like to say, though, on that is that I've often said on this channel, and I still say it, I really don't think evolutionists understand what we believe on created kinds. I really don't. Um, they uh, and anytime a group, and they usually admit to not understanding sometimes about what creating kinds are because but they think we're being ambiguous with the term that we can't define it or something like that. But that's actually false. We've actually defined it several times, and we were actually being very, very explicit to what a created kind is. One of the problems is that they treat the modern day classification system like it is universal, like it's a universal fact of all time that would have been true in the Bible times it is today, and that's not the case. Linnaeus did not discover the way these things are to be classified. whether he invented or grouped them in such a way. In fact, the modern classification system actually changes over time. They change what names they give them. They change how they group them. Some things that they label as species, they end up changing and labeling as not. And it isn't because they're evolving or anything like that. It's just because the fact that the classification system is just dependent upon how you choose to group these classifications, these animals. However, the biblical kinds was created back when the Bible was created or written, when the Bible was written. And that's when we see created kinds in Scripture. And obviously, YCs get their position from the Scriptures on created kinds. It actually commits a word study fallacy to sit there and try to take the modern classification system, how people are defining these things today, and try to apply it to how the Bible writers defined it then. So there's not going to be a specific set uh, in the modern classification system, because the modern classification system wasn't invented at the time that the Bible was around. That people were writing this. So if uh, so the word created kind cannot mean exactly family or exactly genus or exactly species. What it basically means is that it's basically a genetic group of animals that are related to each other genetically, um, uh, uh, along that particular lineage, and it's distinct from other created kinds that have separate lineages, have separate ancestry. And so that is how created kinds are actually defined. Uh, and if you're trying to compare it with the modern classification system, then what we argue is that sometimes, usually it falls around family. Doesn't always, but usually it falls around family, but doesn't always fall around. Sometimes it is it falls around the genus, or sometimes somewhere in between. Sometimes it'll fall above family in order. When I did my interview, we're going to be talking a little bit about that, because she actually defines Predacon, so I can show you, what we've actually defined it as, and sometimes the birds will be closer to order, what we call order, which is above family. So it's possible that that can happen. It all depends on um, whether or not if they are genetically related to each other. Sometimes we have to do some genetic studies to figure it out. It happens, um, but if they're not genetically related, if they don't have a common ancestry with each other, if they interbreed with each other, they are definitely part of the same kind. Now, not interbreeding doesn't mean that if they're not part of the same kind, because different things could affect whether they interbreed with each other, such as mutations, which happen after the fall of the world, not as a result of creation, but happen after the fall. And so mutations could set in. And also, in addition to that, there's size differences. There are predatorial differences. What I mean by that is that they differ on where they are in the food chain. And so, take a lion and a cat, they don't interbreed with each other, even though they're genetically related, because there's a massive size difference. Plus, of course, the lion would eat the cat. So, obviously, they wouldn't interbreed with each other as a result. Um, uh, but uh, but they are genetically related in that. But if they do interbreed with each other, they are definitely related. And so we're going to talk a little bit more about that later. But if they interbreed with each other, they are definitely related to each other. All right. So, uh, so they have this argument, right? They don't fully understand created kinds, and they say, "Oh, well, this destroys family. The classification system of family level overloads the arc." All right. Erica, when she sent me back the reply, sent me back a particular reply, an email, in which case she laid out the important parts of the paper, and among that were certain challenges that she thought was relevant in that. Now, just to be clear, the paper that we're going to be talking about today does not actually talk about criticons at all. Okay, for either my favor or Erica's, or evolutionists. It doesn't actually talk about criticons per se. So both me and Erica are basically working off the implications of this paper rather than the um, the express statements concerning what the paper actually concerns. What the paper is doing is it's looking at it's trying to showing that they reconstruct the entire Y chromosomes of these particular animals as well, and compare them, genetic comparison to the um, the Y chromosome, the completed Y chromosome of the T2T, which is the human Y chromosome. And they also was trying to figure out why these Y chromosomes are so divergent from the human Y chromosome. Why? Because they remember they think that all of these things are related. In fact, they think all life is related. Um, but they definitely think that they think that chimps and humans are closely related, and so but they're getting divergence of things that they think are related, especially closely related, and so that's a problem for them. And so they issued out what I've called a rescue device, and they assume rapid evolution, and now recently they talked about what sperm competition, and we're going to be getting into all that here in a second. But first, I wanted to show Erica's email, and just as a full disclaimer, I actually have Erica's permission to show this particular email. I actually got it recently. I waited a day for her to respond back. She usually gets really busy. I mean, she'll respond back eventually, but if she gets really busy, it might take her a little bit. So I had to send her another email today, telling putting on there, time sensitive, so that way, because I got to make a video here, and uh, and this is time sensitive to get this responded to, or get her to confirm uh, uh, that she don't mind me quoting it. Now, typically, I don't usually ask permission to quote somebody because I don't actually need permission to quote somebody, because if they said it, I can quote it. But here's the thing: emails are generally private discussions most time, unless you're dealing with something like group emails or spamming or forwards or something like that, or chain mail, something like that. Usually, in most cases, emails private conversations. And secondly, I know how Erica is, and if I don't get her okay and make sure okay, I won't hear about it. I'll hear about it for the next two response videos before she finally stops talking about it. So I figured maybe I could save myself the backlash on that, and her accusations of something unethical or disrespect or anything like that, and just kind of ask her if she's okay with that. But she did, as full disclaimer, she did give me permission to quote what I'm about to quote. So, um, without further ado, let me cite Erica, and throughout the course of this video, I will give a response to everything that she says there, but I'm not going to be responding immediately after. I'm not going to just suddenly give you a response as soon as I read the email. The object of it is that I'm going to be dealing with the topic matters that she brought up in her email, and so that's the objective of it. All right, we're here. Erica's email. Um, uh, from my email exchange with Erica, and this is what Erica says. All right, after she told me about where the paper was, confirming uh, my recent realization where she had the paper leaked, and she said the important parts are talking about the paper. One, it confirms previous predictions as to why there is such a divergence and provides a mechanism to boot. Two, it reveals that all ape Y chromosomes are rapidly evolving. Chimps and bonobos are only 60-70% similar. We'll be dealing with that soon, so you'll get a response to all this. Meaning this can no longer be proposed as a just quote unquote just so story for hominins. This also means that you cannot have an quote unquote ape kind and a quote unquote human kind. You can only have a different kind for virtually every ape species, which kills the quote unquote kind definition at the family level and overloads the arc. Three, it confirms that that humans and chimps are 96 to 98% similar. Not sure why she said that. That's actually inaccurate, but we'll cover that. In sequence identity on both X and Y, these are fully sequenced. So Tompkins is even further about it. Four, it reveals why and how certain genes were lost in the pennines. Pennins. I don't know what you mean by that word because I can't seem to find a definition for it. So I'm not sure if that's a mistype or some I don't know. And characterizes subpopulations as well, demonstrating that the Y shrinkage and divergence is still actively happening. Um, the other papers do help make the case. This one is the most recent, and it is definitive. From email exchange between me and Erica from Guts and Gibbon. All right. Um, a lot to respond to there. Um, and she made lots of mistakes there, but we'll get into all that. Um, but just to kind of discuss real quickly the situation with the Y chromosome. The Y chromosome is something that I'm getting into only recently. I haven't really been delved into that discussion for a very long time. Other people have engaged into the subject matter of the Y chromosome, such as Donny Budinsky from Standing for Truth. But I haven't personally done it as much. I am going to be doing a Y chromosome video. That's the relevance of all of this for my Are We Apes series that's going to be airing this month. Um, the video for the Y chromosome won't be airing this month, but the series will start this month. And in that series, I do plan on doing a Y chromosome video. I was hoping to do it with Dr. Jeffrey Tompkins. I'm not sure if that's going to happen or not. I'm praying about it. I know Tompkins is praying about it, but the situation, I'm not going to get into his personal details that he told me, but uh, you know, he might not be able to come on there. Hopefully, he can. Hopefully, but there's a possibility that he might not. All right, but anyway, um, but the Y chromosome is more stable than other chromosomes. Okay, um, and it's supposed to be less evolved than other chromosomes um, because of its stability and because the fact that if it evolves at all, it wouldn't evolve that much because of the fact that that the evolutionists believe that there's only been about 6 to 7 million years since our split, and so it should be remarkably more similar to human, but obviously it is not. So evolutionists are trying to figure out why it's so divergent and things they just know that they are related, and um, uh, so we're going to be discussing that. First, I want to cite Tompkins on that. All right. Tompkins did respond a little bit on the discussion on the Y chromosome. He said the Y chromosome has no homologue to pair with for extensive recombination. We'll talk about genetic recombination too when we get into the so-called quote unquote mechanism that they think they've got. There are a few sites that are thought to recombine with the X chromosome. The Y chromosome is actually more stable than the other chromosomes. That's why Nathaniel Jensen used it for his ancestry research. This is actually a citation from Tompkins's book, um, Chimps and Humans, and this is what he said. Given the low level of recombination, because well, again, we're going to be talking about that here in a little bit. The Y chromosome does not recombine with does not recombine with the X, and so that's called genetic recombination. But it doesn't recombine. So it says, given the low level of recombination and DNA sequence variability on the Y chromosome, the human evolution model encounters the insurmountable problem. The human and chimp Y chromosomes should be considerably more similar to each other. In fact, if human evolution is true, the chimp and human Y chromosomes should be the most similar to each other in the genome because they are the most stable, having the least variation. However, they are the most different of the chromosomes in the genome between humans and chimps. This totally befuddles the evolutionary dogma of human ape evolution. Dr. Jeffrey Tompkins, Chimps and Humans, a geneticist discovers DNA evidence that challenges evolution, page 68. So that means that they have to figure out why there is such low variations between humans and chimps. Now, before I touch into that, I do want to be able to confirm, because we're going to be digging deep into this. I do want to confirm what we believe on Credicons, because we have defined Credicons for them lots of times. Like I said, the Linnaeus classification system did not exist back in biblical times. It is a word study fallacy to try to take modern terminology and apply it in the past into a past word. In this case, created cons. Created cons does not mean the same thing exactly for each one of those things. It's usually a broader classification system. It usually is. Um, in most cases, it will be around family. Sometimes it's genus, sometimes it's order, sometimes between family and genus, and sometimes it may even be at the species level only in situations where we're dealing with monotypical animals. What are monotypical animals? A monotypical animal is an animal that is, or is a species of animal that is the only one left of its kind. That means it could have had several other species within its kind at one time and that went extinct for whatever reason. But presently there is only one species within that kind. This doesn't usually happen. The vast majority of the time has multitude of what we would call species within a kind, because kind is a broad classification. Um, but in cases like monotypical animals, such as the duckbill platypus, for example, will only have one species of a given kind. Okay, that happens very rare, but sometimes it happens. Now, Erica in her email is doing well, she's got a number of fallacies of logic, but one of the ones she's doing is what's called a hasty generalization fallacy. In logic, there are different types of generalization fallacies. One type is called the sweeping generalization fallacy, also known as the fallacy of general rule. This is what Bart Ehrman commits a lot of times. Like he'll say, well, there's low literacy rate in Palestine, therefore the New Testament writers couldn't have written the New Testament, but that assumes that kind of argues that, okay, since it's generally true, because most people would accept this, generally true that there was a low literacy rate in Palestine. That doesn't mean the New Testament writers couldn't write in Greek, or couldn't read or write, because it wasn't universal. There were people that knew how to do that. And of course, homeschooling was popular because they didn't have public schools back then. So homeschooling happened a lot. But the point is that he's making that fallacy where he just kind of assumes that because it is true, generally speaking, that people can read or write, therefore it's specifically true of those individuals. That's called the sweeping generalization fallacy. Now, there is another fallacy in logic and generalization that is the opposite of that. It's called the hasty generalization fallacy. Basically, what this does is it takes a few examples, like a handful of examples, and then tries to generalize them to be included over the whole group. In this case, Erica is assuming that if there are monotypical animals where there's only one species, and therefore there's only one species within the kind, that particular kind, that automatically that means that would be true of the whole. But that's not the case. The vast majority of the time, it includes a multitude of what we would call species, because kind is a very broad term. Um, Depending on where we are, what we're talking about, depends on how you would be able to classify it. Because the modern classification system is, well, modern. It's something that we have chosen to group them, and it's constantly in flux. It's always changing, always, because it's not universal fact of all time. It's something that we have chosen to group them, and I don't think there's anything wrong with choosing how to group these. I'm okay with that. The only problem I would really have is with cladistics, where you just kind of name them or group them according to what you think is their common ancestry. I have a problem with cladistics. Um, I would have a problem with evolutionary assumptions involved in a lot of the ways in which they're being classified as. I would also have a problem with trying to apply this classification system as if it's universal, as if it's for all time, rather than something that's only been less than 300 years old. So you can't take that and then extrapolate that back into the past, because all the way to the biblical times before this classification system was even invented. So obviously, this is not what they had on their mind when they talked about created kinds. And since YECs get our understanding of created kinds from the Bible, this is not what we're talking about when we're talking about created kinds. Rather, instead, when we do talk about the modern classification system, we say, we don't definitively say it's always family. We never say that. We could say it's close to family, and in many cases, it probably will fall in the family level. But it doesn't sit there and do that in every case, because the modern classification system is man-made. It's invented. It did not exist during the time of the Bible, when created kinds was actually referenced in Scripture. So, but don't take my word for it. Here's Karina Altman defining what a created kind is. What are created kinds? I know that they're also referred to as baramins. Could you describe that for us?
Yes, baramin is just the Hebrew term for created kinds. So the Hebrew bara means created, the Hebrew min means kind. So baramins, created kinds. They're interchangeable terms. So created kinds are the categories of life that God created 6,000 years ago. So the Bible tells us in Genesis that God created the animals according to their kinds. Later, he brought animals to Noah to board the ark according to their kinds. We see this term mentioned many times throughout Scripture. There is some confusion because in today's society, we're often used to talking about animals through the term species. And in today's world, a created kind is not the same thing as a species. So species typically refers to the most specific level of animal classification, which we'll get to shortly, I think. But a kind is a much more broad term. It usually encompasses multiple species. So for instance, you have the horse kind, or the equine kind includes horses, donkeys, zebras. The dog or canine kind includes wolves, coyotes, dogs, right? The feline or cat kind includes tigers, lions, leopards. So animals within a kind share the common ancestors created during creation week. They share genetics. They can often hybridize, but basically they're a genetically related group of animals that God created. They're today are descendants from the created kinds God made 6,000 years ago.
Right. On the modern classification system, though, would you say that they're mostly associated with family, or would you say that it just depends on?
It really depends. So for instance, with birds, a lot of times the bird kinds often fall at the order level, which is one higher than family. Sometimes with amphibians, they may fall at like the genus level, which is one lower than family. So we generally will say kind of family level, but it is not always consistent, because the terms that we use to classify animals today are man-made terms, right? They're not necessarily biblical. So when we're going about biblical kinds, they don't really fit neatly into a man-made category. So that's where we have to go into the genetic studies. But typically, your kind is going to fall at the family order-ish level. Just depends on what animals you're talking about.
Right. Um, I know that we're going to be talking about that here in a little bit as well on the man-made classification system. Um, but I would like to ask you one other follow-up question on species. Does it fall into the species category at times? I've read an article that says sometimes it does.
Potentially, especially if you have monotypic animals. So I'll get into this later too, but monotypic animals are animals where they're basically the only one left of their kind. So they're going to be the only representative in order, family, genus, species, all the way down. So it is possible for that to be the case, but generally a kind is going to be a much more broad term than what we think of as species.
Right.
All right, so you can see that and that's on my channel. I even made a short of some of the on her defining what a created kind is. So we have defined it many, many times. So this claim that we can't define what a created kind is false. I think evolutionists just like to make certain arguments, even though it's been proven and disproven over and over and over again that it's false. That it's constantly proven that it's false. It's constantly been disproven the claim, but they still make the argument anyhow. But we have explicitly defined it. Um, what they might probably mean is that we can't put it neatly in a package deal within their modern classification system, which did not exist in biblical times. We can't do that because, well, the modern classification system is man made, it was invented. So obviously, it's not going to fit into a neat package there because of the fact that it's invented. Um, but it does actually, we have actually defined what it is. Um, in addition to that, and you might wonder why I'm going to be talking about created cons a lot as far as defining it, because Erica's statement in the email seemed to suggest that if it destroys the created con at the family level, this would overload the arc. That's the argument that she had made in her email. And I definitely would disagree with that because one, this thing does not destroy it at the family level. Secondly, it doesn't really matter because it's not at the family level specifically. It's just the fact that the modern classification system did not exist. The modern classification system did not exist during the time of the Bible. That's what it comes down to. And um, like I said, I don't think evolutionists understand created kinds very well. Um, and of course, with monotypical animals, you can actually have a species within it. It doesn't happen very often. Usually, it doesn't. Just like Karina Altman mentioned, in most cases, it's usually much higher because it's a broad classification system. But in cases where you only have one species in a particular kind, it can then fall in a single species as a result, or at least what we would call a species. Now, of course, species is kind of a fickle term, so evolutionists defining species is extremely difficult to do because every time they come up with a definition of species, you can always find species that doesn't act the way they think species should act. As Karina Altman pointed out in our interview together, I'll put it up there at the end of the video. You'll see it, and I might link it in the description box as well. But it does an excellent job of talking about these things and defining them as a result. But there are a few cases where it may go in the species level when there's only one species left within a kind. And me and Karina actually, in our discussion, actually talked about the duck-billed platypus as well. And she agrees that the duck-billed platypus would be one of those monotypical animals which has only one, what we call species within a kind. We're going to be talking about that because obviously Erica thinks that we lump all primates up as a single kind. Now, there could be creationists that do lump all primates up as a single kind, but there are creationists that don't. And Donny has actually discussed this on my channel, so I'm going to show that next.
I'll share my screen and show why the model that I hold to, and the model that Christopher Roop holds to, and a lot of young Earth creationists, her argument doesn't provide us with a challenge or a problem, because you'll notice the phylogeny here. This is the separate ancestry model. This is what I hold to, and this is what I've been confirming using mitochondrial DNA, Y chromosome, orphan genes, DNA function, other taxonomically restricted genes, linkage blocks. Okay, so yes, we would agree that a lot of these sequences and DNA elements are species specific. But you know what? It falls in line with our model here. So you got Homo sapiens, humans, that all belong to one kind. And then I would argue that you basically have, within your primates, you have gorillas as their own kind, chimpanzees and bonobos as their own kind, and then orangutans as their own kind. And so I wouldn't argue that your gorillas are related to your chimps. And so if there's species specific sequences or species specific orphan genes, it more or less lines up with the phylogeny I have here. Now, if I was a creationist who said, you know what, gorillas and chimps and bonobos all belong to the same kind, then there might be a challenge. That might be something I need to work out, right? But I think the data suggests that gorillas and chimps are their own specific kind. And what's funny is the Y chromosome data, Brian, trying to find it real quick for you, actually supports this. Notice this. This is from the secular literature. This is from the conventional literature. This is from a paper, The Y Chromosomes of the Great Apes, 2017. Notice the differences in Y chromosome. You got your human Y chromosome, which is totally different to the chimpanzee Y chromosome, half the size, totally different in gene content. This makes sense. Humans and chimps are separate created kinds. But you'll notice the gorilla Y chromosome is actually more similar to the human Y than either are to the chimpanzee Y. And so again, this confirms what I'm saying. Humans are a separate kind. Chimpanzees and bonobos are a separate kind. Gorillas are their own separate kind. And then your orangutans are their own separate kind. And so you have multiple separate kinds here within primates. And so sure, some of these genes, some of these sequences are species specific, but overall the pattern seems to fit this phylogeny.
All right. Again, you heard Donny, right? Donny has been throwing that out for a while now. So she knows that a lot of creationists, and Dr. Jeffrey Tompkins too, as we're going to see here in a little bit, hold to the position that different primates are different created kinds. That we don't hold to all the primates being one particular kind. And Erica doesn't. I don't think Erica understands that, but we don't hold to that all primates are the same kind. Now, interesting enough, we're gonna go and we're gonna be looking at the data from this paper. Okay, that's what we're fixing to look at. But first, we're let me quote some quotes on the bonobos. Bonobos and chimps are the same kind. Um, they don't normally interbreed in the wild, and the reason they don't is because they're separated from each other by the Congo River, which is too wide for them to cross and interact with each other. Um, but apparently, when they get together, it's party time because there is evidence that they do interbreed and has interbreeded in captivity. In fact, they've actually one paper I found actually found 1% of the genes in chimp is actually bonobo genes, not similar to bonobo genes. They are bonobo genes, indicating that they did interact with each other and more than likely are related to each other. And so, and our position is that chimps and bonobos, as Donnie pointed out, are part of the same created kind, whereas gorilla and orangutans and chimps are all different kinds. Gorillas are not the same kind as a chimp, and of course, chimps and humans are not the same kind. Definitely not. And so, because that's called as Donny pointed out, the separate ancestry model, and that's the position that we hold to, that these are created kinds. And so, of course, she said, well, the bonobos are 59% to 60% or 65% similar, and that's true. That's the one thing she said about it that was actually true. But we'll get into that and talk about that in a second. But I did ask Dr. Jeffrey Tompkins about that on bonobos, so I am going to show that email first before jumping into the paper real quick. All right. Uh, this is Tompkins' response to the bonobo and chimps from that particular paper. He says, bonobos and chimps rarely interbreed in captivity. They interbreed quite often and are the same kind. Thus, their similarity was the highest at 65.3%. The differences reflect diversity in structural rearrangements, not gene content. See my article below, which shows that humans and chimp Y chromosomes are so different. And he quotes an article. And he provides the link to the article. If y'all want to type that in, y'all can. So, bonobos and chimps are the same kind. And he does something interesting because he points to me to how high. The two species of orangutan are going to be higher, but compared to all the others, it is higher than them. And it pointed us to an interesting little phenomenon that I was able to look at when I was examining this, because those things that are believed to be the same created kinds score the highest, while the ones that we believe are not the same created kinds score the lowest. Interesting. All right, let's go to that paper and we'll see. All right, we're here with the paper and the complete sequence of comparative analysis of sex chromosomes is the name of the paper. And it was published in Nature. It is open access, so it's free. I will include a link to this paper below, and we'll get into it. All right. The first thing we're going to talk about is what the comparisons that they made, and we'll get into the supposed quote unquote mechanism that Erica thinks that they came up with to describe how these variations actually occurred. But we'll get into that. But first, I want to actually show it to you because they actually include, if you go down, they include a graph here of this, and I got a little blow up of that. All right, okay, this is the graph they come up with comparison. The way this works is you cross-reference it with that. Like if I wanted to see what the human on human is, here's human, see 100%. And you know, see this in the diagonal. So that's how that works. So if I want to see humans and chimps, I go to human and chimp, or you can go human and chimp, and you see diagonal right here. All right, so basically you would have kind of like a range here. Essentially, humans and chimps are 26.2% similar to 45.1% similar. And now you say, wait a minute, didn't Erica say that the X and Y chromosome was 95 to 98% similar? Yes, she did in the email, which is kind of odd. I don't know why she said that because that's not what the paper said. Now, the paper said that about the X chromosome, which we already knew that, but the Y chromosome is the one that is stable, that should have very little evolution involved, and that Tompkins said that should not evolve that much, especially within the amount of time scale they're giving it to, since there's so-called split between chimps and humans in their, or in the, between apes and humans in their paradigm. All right, but as you can see, the Y chromosome is 26.2% to 45% similar, which is very little, indicating that this is completely distinct. All right. Um, now, one of the things you might notice on bonobos, okay, go to bonobos and you go all the way to not human, but the human bonobos, by the way, are also really low. But if you go bonobos to chimpanzees right here, you notice 65%, and they're also 59.6%. So between 60 to 65% similar. Erica said in her thing 60 to 70% similar. I think she was rounding, like this right here is like 59.6%, so she rounded up to 60%, and this is 65%, so she rounded up to 70%. But uh, but that's the one thing she was actually correct on. Now, chimpanzees and bonobos are actually the same kind. They can interbreed, like I pointed out earlier. So, and Donny has also said that these are the same kind. All right. So, if they are the same kind, then the objective is that they expected them to be, high, right? They probably expect them to be 90 something percent, but that just assumes that they're closely related. But the point is that they're higher than all these other numbers. And you also are going to notice something else: the S orangutan and B orangutan. These two are two species of orangutan, so they are actually the uh, same kind. Now, if you look at them to each other, B orangutan and orangutan, notice 67% to 87% similar to each other. So it's pretty high. All right. But notice that those are higher than all the other surrounding numbers. Same thing with this. It's higher than all the other surrounding numbers. So these two right here and these two that are the same kind are high numbers. The ones that are different kind. By the way, gorillas and orangutans and chimps and humans obviously cannot interbreed with one another. Humans can interbreed with humans. Chimpanzee can interbreed with chimpanzees. Orangutans can interbreed with orangutans, and gorillas can interbreed with gorillas. But they cannot interbreed with each other, and that's interesting because those ones are really far apart in terms of the percent similarity between them and each other and human Y as well. So you can see that they are very, very different. And so this is looking extremely like the created kind model. I mean, if you look at it, this right here is high, this right here is high, these are the same kind, this is the same kind, these are not. So you can start seeing that contrast there. So they have to come up with some sort of rescue device to try to explain this difference here. And so the rescue device that they've come up with is to assume one, they assume that it is rapidly evolved. Um, Erica assumes the same thing because of the supposed mechanism. They have previously suggested that as a mechanism for the X or that Y chromosome before. It's called sperm competition. What is sperm competition exactly? Basically, it's kind of gross, but essentially, you got organisms that are, to put it mildly, competing for the prize. And so I think Wikipedia had likened it to a raffle. You know how the more raffle tickets you buy, the more you increase your chances of winning. And lottery, of course, isn't like that, but raffling is, and you increase your chances of winning. You buy more raffle tickets. Well, essentially, that's what they're doing. the The idea is that you're putting an overload of Y chromosomes in there. Now, as already pointed out, Y chromosome does not recombine. They don't. It does not have any kind of recombination. So the paper tries to point out, well, the lack of recombination coupled with the overload of Y chromosome, it's kind of like a dominoes effect type of argument. Like, sperm competition leads to a lot of Y chromosome, a lot of Y chromosome leads because it doesn't recombine. So maybe it leads to mutations, and these mutations can lead to substitutions and create this uh, rapid evolving sort of situation where it would degrade the Y chromosome really fast. That's the object of it. And in a minute, we're going to see that's not the case. But essentially, that's what it comes down to. So I am going to read a quote here from the paper itself. The phylogenetic analysis of multi-species alignments methods for the X chromosome and separately for the Y chromosome revealed the expected species topology but detected higher substitution rates on the Y chromosome than on the X chromosome for all the branches, consistent with male mutation bias. For instance, the human chimpanzee divergence was 2.68% on the Y chromosome and 0.97% on the X chromosome. For the Y chromosome, we detected an 11% acceleration of substitution rates in the pan lineage. That's the genre of the genus of the chimpanzee, and a 9.2% slowdown in the Pongo lineage, compared with substitution rates in the human lineage. Significant relative rate test p-values in supplementary table 13. Okay, for the X chromosome, substitution rates were more similar in magnitude among the branches, meaning the different primates. These results indicates a stronger male mutation bias for the pan lineage and a weaker bias for the Pongo lineage than for the human lineage. Strong male mutation bias in the pan lineage is consistent with increased sperm production due to sperm competition. Notice it says inconsistent. It does not say it proves, which basically means that they think that this data is allows for the possibility that sperm competition is the result of this. Okay. So essentially, they say the substitution rate is about 11%. All right. What is the substitution rate? Is the rate of substitutions. Okay. What is substitutions? Genetic substitutions. Um, it's exactly what it sounds like. The bases are claimed to be substituting for a different base. So it used to be a different base there, but now it's another base there instead. Now, the problem with assuming substitutions, and I actually checked this out with Dr. Rob Carter to make sure that my thinking was correct on this, but you have to presuppose common ancestry. And let me explain why. Essentially, you have to have the same, you have to be able to know what the original sequence looked like. Okay? Because if you're substituting a base for another base, well, how do you know that it's a substitution in the first place? How do you know the substitution changed over time from this to this? Well, how do you know that? Um, and the way they usually do it is that they look at what they think are related to each other, common ancestry, and they look at the primates and things like that, and they see that, oh, this sequence looks like this, then maybe it evolved into this. And so that's the object of it. But that presupposes common ancestry. So in order to claim that has a mutation rate of this, and assume that this is evidence for mutation, they have to assume it's evidence for substitution, which then they assume that it's evidence for substitution because they assume that these things are related to each other. That's it in a nutshell. They believe that it is that these things are related to each other. That's why they think that this has a substitution rate and that sort of thing. In reality, though, this would not be evidence for the Y chromosome or for sperm competition. Um, and even if it was, as the paper said, it's only consistent with it. So it doesn't even say it. Even in the paper, it doesn't say they prove sperm competition as a result. They might think it happened, but they don't. They don't actually have evidence that it happened. Instead, what they did presuppose in a circle of reasoning, that that chimps had and apes and humans all had shared a common ancestor, that they're all related, and the whole paper. By the way, this whole paper, probably forgot to mention this at the beginning. This is one of the first things that I actually figured out about the paper. It is richly thick with evolutionary presuppositions. It's all through it. When they refer to primates and apes, they always refer to them as non-human apes. The implication is pretty obvious. They're referring to us as apes as a result. So the evolutionary presuppositions just fill this paper. And so I had to go through tons and tons of papers stomaching a lot of the evolutionary presuppositions that were filled in many of these papers that I was looking over. But essentially, there are two different groups. One group that thinks that the Y chromosome is going to evolve and degrade into nothing, while others think, no, that's never going to happen. And of course, in reality, there's a lot of things that would stop it from degrading, or stop it to a point, uh, it, regardless, even if you think it happened a little bit. Um, there are certain genes within the Y chromosome that are essential for life, and many think even natural selection would prevent this from happening, because of the fact that these genes are critical to life. There's even some genes that are called control genes, which actually regulate or control, other genes that are essential to like embryological development, that sort of thing, turning them on and off. And so, at a certain developmental stage. And so the Y chromosome isn't just about determining the male gender. It actually does more than that. And there are reasons they're actually given. And I actually have a quote. It's on my slide. I got the website up too, but I'm going to show my slide, in which case I'm going to show this particular citation where they actually argued, and these are evolutionists, they clearly have evolutionary presuppositions, but they argue that the Y chromosome isn't degrading or evolving, or get to that point where because they're trying to argue that it's never going to get to a point where it's going to degrade away. But in the process of doing that, they give examples or things where they know that the Y chromosome, that would prevent the Y chromosome from deteriorating like that, or at least to the degree that is being claimed by other evolutionists. All right, let's get into that quote. Here we are. This is it was I think it was the or University of California or Berkeley, but anyway, I'm calling it the Berkeley citation because it actually has berkeley.edu in the title. So, all right, what they said was this: last month, two different research groups published studies that explore the function of the genes still present on the Y chromosome, and that compared the human Y chromosome to those of other mammalian species. They found that even distantly related species share most of the same functional Y chromosome genes. When they say distantly related, they mean other organisms, possibly even other primates, that they think are more distantly related than, say, humans and chimps. Suggesting that the species have not continued to lose genes since they shared a common ancestor many millions of years ago. Remember, assuming evolutionary presuppositions here. Furthermore, studies of these retained genes showed that many of them were expressed all over the body and seemed to be protected by strong natural selection. These findings imply that Muller's ratchet acted quickly after recombination slowed, ruining many genes in short order, but that this loss wasn't random. Less important genes were lost, but the important halted with a few key genes. These genes have not degraded in tens of millions of years and aren't poised to do so. That's well after the supposed split between our common ancestor. They seem to be important that mutations in them can't accumulate because any individual with a mutation damaging one of these genes would die or be unable to reproduce. Our X chromosomes also contain copies of these genes. Females need them just as much as males do, but they are so important that a half dose just won't do. XX individuals get a half dose of the gene from each of their X chromosomes, and XY individuals get a half dose from their X and a half, or from the X and half dose from their Y. These genes are control genes, what I was talking about earlier. They turn on and off cascades of other genes that must be expressed in many different cells of the body. In fact, many of these genes are among the first to be activated just after the egg meets sperm. Even before developing, embryo has implanted in its mother's uterus. Developing embryo has implanted in its mother's uterus. This turns our previous view of the Y chromosome on its head. Yes, the Y contains genes needed for sex determination, but it also contains many control genes that are critical for survival in general and go far beyond the development of sex organs and sperm production. The Y's list of genes is short but very sweet, and so this bearer of masculinity is not evolving away anytime soon. That's an understanding evolution. I put Berkeley Evo in the news, found at, and I got the link right here. So there are many different factors that would actually prevent this from actually taking place. So it has been and successfully argued that this is not the case, that this would not, that even if you could try to degrade it a little bit. So why do evolutionists bring stuff like this up? Rapid evolution, sperm competition. Why do they bring this up in the first place? Because this is a rescue device. Anytime a person's worldview or paradigm is challenged, or more specifically, threatened, people will try to come up with rescue devices to try to count for it, because they have to count for it within their paradigm. Because their paradigm claims, okay, the split happens about 6-7 million years ago. Why are we experiencing this? This kind of variation. Uh, Y chromosomes are pretty stable. Shouldn't have that much time for them to evolve. I know we'll say they rapidly evolved, and we'll argue the reason they rapidly evolved is because maybe there's a lot of sperm competition. There's an overload of Y chromosome mutations, create substitutions, and then this and also of course mutations. One of the things mutations can do is they can turn genes off. So maybe there's an overload of mutations, and these mutations turn the genes off, and that's what caused us, to have 26% similarity between Y chromosomes and human Y chromosome and chimps. And but this is all just a rescue device. At the end of the day, it's looking very much like, and one of the things that I was really impressed with on the study. I do think that the writers of the study was trying to be honest. I am not in any way accusing them of dishonesty. I believe they do have evolutionary presuppositions. I believe if you ask them, they would probably be against our position naturally. They are evolutionists at the end of the day, and there's evolutionary presuppositions all throughout this paper. So it's clearly that they really believe in evolution. But the implications of this paper, of what they're saying, it's looking very much like created kinds. And so instead of seeing that this paper is against created kinds, I'm saying this is very favoring it. The only way you could argue that this is against created kinds is if you don't understand what a created kind is, which evolutionists don't. If you try to lump all primates up as a created kind, then you would have a problem. But we don't lump all primates up as a created kind. I mean, there could be some creations out there that do, but usually, uh, especially in recent times, we have not done that. because the created kinds don't necessarily fall in the family group. It just depends on where you are in the classification system, and because our classification system is man-made. It's not biblical. It didn't exist in ancient times. It's only existed for the past 300 years, and so it's what we've chosen to classify them as. But this is not the way the Bible chose to classify them as. And so we're going by with what the Bible shows how we classify it. But the data seems to be very consistent with our arguments here. Um, we saw how bonobos and chimps and the two species of orangutans score the highest as far as percent similarity with each other. But when we compare that to other organisms, however, other primates, they don't score the highest. So what we see in the modern classification system, it's not adding up, but it's very consistent with created kinds. And I think that this is one of the problems that a lot of the Y chromosomes face, is that it actually does fall in the Y chromosome debate, the evolutionism. I think lots of different things disprove evolutionism, but this is one of them. You know, evolutionism being a belief system in the theory of evolution. They believe in evolution. They think it actually happened. They speculate on the past, everything they do, and they assume, evolutionary views. And but it definitely shows, or this is where created kinds shine the best. One of the ways in which created kinds shine the best is with the Y chromosome. And we saw that in the paper when we looked at the graph. These people don't have evolutionary presuppositions. The paper's not even about created kinds, but we can actually look at the graph and tell the four different things were there, right? Two pairs of that we think are actually created kinds, right? Chimps and bonobos, and the two species of orangutans. Okay, part of the same kind, scored the highest, while everything else, including the comparison between chimps and humans, scored the lowest. Like with humans scored between 26.2% to 45.2%, I think it was. So 26% or 26% to 45%, similar, which indicates that they are very distant from each other, even if you assume evolutionary presuppositions. They are looking very much like created kinds, but they're not looking like what they're thinking they would look like. Like all primates is grouped up together. And let's go ahead and classify humans as primates. That's the evolutionary idea, right? Just classify us as primates. But when we look at it, it's like, wait a minute, we are very distinct from it. We do not interbreed with primates, and we have morphological differences. We've got genetic differences. We are clearly different from primates. So labeling us as primates does not make us primates. Labeling us as apes does not make us apes. And we're going to be talking about that uh, this month, and throughout the next couple months or so, as we're dealing with this new series I've started, Are We Apes? And so join me for that if you want to. Don't forget to subscribe to my channel. Don't forget to like the videos, give the video a thumb up. That helps me out, gets this information out to more people. It's not to give me a pat on the back or something. It actually helps YouTube promote this video. The more people like the video, the more they're going to promote it, and it gets the information out to more people, and that's what we want. A lot of times critics will come on here and try to give it a thumbs down so they can sabotage the video. Usually I always get more likes than dislikes anyhow, but it also kind of helps combat that, because the critics are trying to keep this information from going out, whereas we obviously want the information to go out to a lot of people, to as many people as possible. So that's why we give this video a thumbs up. It's so YouTube can help promote it. Don't forget to share it with others as well. That help get it out there as too. And also, don't forget to hit that notification bell so you can be informed of all my future videos. I've got an interview that's literally around the corner. I've got Dr. Georgia Purdom coming on here Tuesday to have a discussion with me. The first episode of the of Are We Apes series, and also I've got two interviews that week. Also, additionally, one with Dr. Jason Lau, day after my Dr. Purdom interview, and a few days later, I have an interview with Dr. Carl Werner. These two videos will be on the Genesis series as well. And I also have a live interview by the end of this month. I sure hope I did not bite off more than I can chew. But I'm going to have a very busy month, especially going to have a very busy week. So stay tuned for some more interviews and discussions. And we will probably continue discussing the Y chromosome issue. I know I'm going to have a Y chromosome video for my new series, Are We Apes? And so I would love to y'all join me on there and check that out. So we're going to probably be exploring this a little bit more. It's something that's started to make its way on YouTube a lot. But anyway, this don't worry about it. Again, this is a lesson for us creationists. Don't worry about it when you have evolutionists who say, "Hey, we got this paper and it disproves what you think on created kinds." Um, and in reality, it actually doesn't disprove what we believe on created kinds. They just don't understand what we believe in created kinds. And so that would be a lesson for us creationists when a group who don't understand what created kinds are say they got something that refutes it. It makes you wonder if they got something that refutes their misrepresentation of created kinds rather than what we actually believe on created kinds. Now, when we actually look at the paper, instead of de-affirming created kinds, it actually affirms it. You know, by implication, of course, because the paper is not directly about created kinds. But we can see that it's extremely consistent with what we believe on created kinds. That humans and chimps are only 26 to 45% similar in the Y chromosome, and we see that bonobos and chimps are very similar, between 60 to 65% similar. The two species of apes are really similar to each other, around 85% similar. And so that's what we expected. And so this is perfectly within our expectations of the Y chromosome and what they should find, and they did find. Um, Dr. Nathaniel Jensen had replied to this. I do want to show that email real quick. This is what Dr. Nathaniel Jensen responded to, particularly what they believe to be their rescue device there. He says, I'll short circuit the argument. I almost don't care what they invoke to explain things. What matters is the standard that they themselves have erected, and which creation science now had met and exceeded in spades. What testable predictions does their explanation hypothesis make? And if there are none, then their explanation is junk, pseudoscience. And I will second Dr. Nathaniel Jensen's statement, because what did creation science do? They predicted everything that we would expect to find, and did, when they even when they fully sequenced the Y chromosome. All right, what does human evolution would predict? Well, the human evolution would predict, and it should be degraded in things that they think are distantly related, right? Because it would be no more. But yet there's still plenty of Y chromosome there as well. So here's the thing: if they can't actually make testable predictions, or if they do make a prediction and it's found to be false, then this shows that what they're claiming is not actually science. It's pseudoscience. That's what Dr. Nathaniel Jensen was saying. It's pseudoscience. It's not actually science. They can't even make a testable prediction with it. You can't verify what they're saying. And when they do say it, it doesn't fall through with the data. It clearly is just a rescue device that they're coming up with to try to justify what they think on the matter. I hope this has been helpful, but I gotta go now, and just keep in mind, no matter what evolutionists throw at you, always stay in the know.